Okay, this is, well, not sure who this is, but I've been following the two-stage oscillator for a while, and this is my first attempt to build one. So here is my, it's kind of dark here, but I decided to record anyhow. Here's my pivot point, and my pendulum pivot point, and here's my arm. So I got from right here to right here, I got about 10 inches, and then from this point out to the end is about 48 inches. My pendulum is about 9 feet long, and it's kind of dark, but my first attempt to recreate two-stage oscillator. Pretty happy with the design so far. It's going fairly well. I'm able to adjust this thing up and down, my pendulum up and down a foot or so. And my next problem is trying to figure out how to power this pendulum with falling weights. I'll probably be posting my next video with ideas that I've come up with to try to figure out how to power a pendulum with falling weights. That's efficient, and yeah, there's a bunch of problems that we're going to need to address with that, but my bar is actually 2 bars. I have it fastened there with a C-clamp and a chain, but that I-beam there moves very little up and down. I actually can't even see if it moves up and down. The only thing I've been able to see that there's any movement is my actual lever bar. But we got heavy duty industrial bearings, 1.25" rod for my axis points for my axles, or whatever you want to call it. And here I got 140 pounds swinging, so should be interesting. Let me give you a close up here. Okay, so there I got weights. I can add a bunch more if I need to. Right here is actually a nut. This is round pipe. This is a nut, so I can turn this. And these right here are only set screws, so that I can. There's a little bit of wiggle room in here, so I can adjust this thing this way. And I can also adjust it this way, you know, just to make sure my pendulum's straight. But this bar, this round inch bar, comes down to about down to here, I would say. Well, actually about here, somewhere in here, and this screws on. So, any ideas on how to power this thing? On this side, I was going to go with the electric servos. I have a friend who's you know, got RC motors, and use a brushless magnetic motor, hook it right onto that axle, and I could feed it. I could program it very simply to feed it, you know, 20 amps or 21 amps or 30 amps, you know, just a constant, and I could you know, hook up sensors and could get this thing down to science. The problem I was running into was you know, this action over here is going to be going up and down about 1 inch. This action here, you know, whatever it comes out to, half an inch, probably not 1 inch, maybe half an inch at the most, 3/4 inch at the most. So here I'll have between 1 inch and 2 of motion. I'm not certain how to convert that to electricity efficiently. So we're going to probably be running into some problems with that idea, so I decided to go with mechanical instead. Just to maybe simplify it. I mean, it'd be cheaper. I have metal around here. I have a welder, and I think I can fabricate something here. I guess one of my ideas behind the two-stage oscillator was, it was simple enough that I knew I could build it, and I've been following it for about a year or two on YouTube and seeing people trying to construct their own pendulums, two-stage oscillators, and I was kind of disgusted with all the misconceptions about it, and maybe I have some too, that's fine, but I saw a lot of people that had a lot of movement on this pivot point here, and that's very critical because that's where you lose the energy in your pendulum, okay? And if you move that thing up and down, if this is 140 pounds down here, if your weight is 140 pounds and that thing moves down 1 inch, you lose that. You have to, if you move that down 1 inch while this thing's swinging, that means you have to lift it up again that far. But the key is that this thing needs to be swinging, okay? And when that thing begins its movement down, when this side of the lever bar begins its movement down, it needs to, the pendulum needs to be pulling on it at least the same amount of force as its weight. In other words, when the pendulum is at 90, or when the pendulum is at 45 degrees stretched out, it's not pulling down on that lever bar at all. When the pendulum is, 45 degrees, it might be pulling down close to 140 pounds, but probably not quite. The closer to the bottom of the swing this pendulum comes, the harder it's pulling down on that lever bar. And so, counting in all the friction of the bearings and the friction of the feedback loop and everything, we should have at least 150 pounds, probably close to 200 pounds of downward force on this pendulum bob, on this axis point. This pendulum bob should be pulling down at least 200 pounds before this thing starts moving at all. And that's the key, because if you move it down 1 inch, if you move that lever bar down 1 inch, 3/4 of an inch, when the pendulum is pulling down 200 pounds, we only need to lift that pendulum bob up 3/4 of an inch again. But when we pulled it down, we were bleeding off, or we were pulling down 200 pounds, or whatever it is that this thing pulls. So that's one thing that I think a lot of people didn't address. Their bar was moving too soon to be able to be efficient enough. Some of the other problems some other people had was not having sufficient length for this side of the bar, for the output side of the bar, and I don't know. I think that this may be a little too far, but then again, I can always put my output, anywhere along the length of that bar. I don't have to put my output way at the end. So that's one thing we can play with. The other thing I was concerned with, and this is one thing I'm not sure what I'm going to do yet, but as you can see, actually you can't see really well here. It's dark. You can see there. Let's go this way once. this pendulum pivot point is lower than this lever pivot point, and 3-4 inches. That's a problem, because when a pendulum is swinging one way, it's gonna pull harder at a different spot than coming back. It's gonna the force that it pulls down is going to be different depending on which way this pendulum is swinging, because we have these bars up and down. Now, I'm not sure if that's gonna be a problem. If that's a problem, I'm gonna have to move this pivot point up. I don't want to, because at this point I can get a full 90 degrees of swing. I can get a full 90 degrees of swing because my pendulum bar, my pendulum rod, does not hit that axis point. So I want to keep it this way so I can get a full 90 degree swing, but I don't know if I'm going to be able to, if it's going to cause too many anomalies on this output, if it's going to be inefficient. So this is my plan. Stick a lever on this end, and then power this pendulum with attachments onto this bar, because this seems to be moving up and down, and we won't be able to fasten our powering mechanism onto here because of that movement up and down. It might, with the accuracy we need, we're going to probably have to keep it exactly with that pivot point. So my plan for powering this thing is with a falling weight, and I have ideas that I'll post later. And the idea for this is to either punch a hole up there upstairs and put a rod up through, lift something up in there, because I probably can't lift something up down from the floor because it's going to be in the path of the pendulum. This pendulum is 9 foot long, so it's going to swing way past this bar here. So I'm not certain how I'll probably fasten this, keep that fastened until I have this project done, learning how to power this thing efficiently and in a way that's going to run for a while, and then calculating exactly how much force is needed to keep this pendulum swinging. So yeah, any ideas on that side would be helpful, and any ideas on this side would be helpful. I thought about taking my problem to a hydraulic shop, but I think hydraulics have too much lag, and they operate under high pressure and are fairly inefficient. They're good for on demand and for brute force, but this may look like brute force, but it's actually pretty intricate, all these inner workings. So I'm not sure. Hydraulics wasn't really a good idea, and also I was thinking about doing it with air, but I'm also hearing that air has inefficiencies even at low PSIs, so I kind of shied away from that. So any ideas, comments, questions, critiques? And this thing's fairly plumb, very plumb in fact, and it's fairly rigid, so we don't have any much left and back and forth movement, and it is on running east and west. The swing of the pendulum is running east and west, so that should minimize some of our swinging and some of that swinging back and forth. Okay, later.